Hi everyone. Today we are going to see Octet configuration and what is Octet role. Okay, so first let's start with the slide. What is Octet configuration means? Do you feel the word oct sounds familiar? Oct means any number you would think of. Think about that. What is the number you say for oct? Octagon. Why do you call octagon the shape octagon? Or octopus. What is a common thing between octopus and the octagon? Yes, you are right. Octagon has 8 sides. See, you have seen the stop signs, right? Stop sign has 8 sides. The octagon shape octopus has 8 legs. So oct means 8. So oct means 8. So what is the connection between the number 8 and the configuration of atom? So let's go to the definition first. When the atoms have 8 valence electron in the outer shell, that configuration is called octet configuration, and which is a stable configuration or filled outer shell. So this is the connection. So when there are 8 valence electrons in the outer shell of an atom, that configuration is called octet because oct means 8. And what is so special about octet configuration? Because octet configuration is a stable configuration. See, when you see group 18 elements, the noble gases, all they have stable configuration because they have 8 electrons except helium. All other elements in group 18 have 8 electrons in the outer shell, which makes them be stable. So they are completely filled outer shell. So my next question is, okay, every atom would love to become stable, love to become octet configuration. But how? How do they become? And is there any rule for that? Yes. Just wait for the next slide. I'm going to present the rule, which is also called octet rule. So, octet rule. What does octet rule mean? Can you guess? You want to think of something? What is octet rule? Here you go. So, octet rule. Let me read this, then I'll explain you with some examples. So atoms tend to gain, lose, or share one or more valence electrons to achieve filled outer electron shell or octet configuration. I would little bit extend that. So one more time, I'll highlight the important things. So atoms tend to gain or lose or share. They do any one of the things, gain or lose or share one or more valence electrons to achieve a filled outer electron shell, or I would say electron octet configuration. Octet or octet configuration. So this rule is called octet rule. So at this point you might be asking a question, how do I know whether the atom wants to lose electron or gain electron or share electron? How do I decide? Or how do I know which atoms will lose electron, which atoms will gain electron, which atoms will share electrons? How do I decide on that? So I'm going to take 2 examples. I'm going to explain you step by step. Okay. Meantime, you can watch the video, and after the video, we'll continue. We'll watch the YouTube video. After the video, we'll continue this particular video. Okay. Take a pause and watch the video, then come back. Okay, hope you enjoyed the video. So now I'm going to take one example. See, in the video, I guess you saw sodium atom. So why don't we take the same example? Example, sodium atom. Okay, so I'm going to draw the atomic structure for sodium atom. Then we will decide whether the sodium atom is going to lose or gain or share electrons. So this time I'm going to put the nucleus just at the dot. That's okay because we are not focusing on the nucleus at this time. We are focusing on the electrons. So I simply put, and I'm sure you all know how to draw the atomic structure for the elements. So for sodium, first I will draw 3 shells. It's in period 3 and it has 11 electrons. So now I'm going to put those 11 electrons in the 3 shells. As we already know, there are 2 electrons in the first shell, 8 electrons in the second shell, so 2 plus 8, 10. Then the remaining 1 electron will go to the third shell. Okay. So now, how many valence electrons are there in sodium? You know, only 1 valence electron. Valence shell is the third shell. So how many electrons are in the third shell? Only 1 electron. So now I'm going to ask you a question. How do sodium get 8 electrons in the valence shell? What are the options the sodium has? Listen carefully, because according to Octet rule, either sodium loses electron or gains electron. So can you suggest something to sodium? What it can do to have 8 electrons in the outer shell? What are the options? Okay, let me ask you the question. Already sodium has 1 electron in the outer shell, right? So to become 8, how many more electrons it may need? Think about that and tell me the answer. How many more electrons it needs to become 8? You're right. It has to gain 7 more electrons. That is one way. Or I would say just lose this 1 electron. Just lose this 1 valence electron which is in the outer shell. So when it loses this 1 electron, now you think how many electrons will be in the outer shell? The second shell will become the outer shell. Now it will have 1, 2, 3, 4, 5, 6, 7, 8. So there will be 8 electrons in the outer shell. So which one is easy? Now we have to decide which one is easy. Whether gaining 7 electrons or just losing 1 electron. Like if I ask you to reach the destination, you have 2 paths. One path you have to walk 7 miles. The other path you have to walk just 1 mile to reach the destination. Which one you would choose? Obviously, you would choose losing just 1 electron. You wouldn't go for gaining 7 more electrons. That's not easy when compared to losing 1 electron. So I want to stick with just lose 1 electron. Okay. So now you see it's going to lose one electron. It loses one electron. Now, after losing the electron in the outer shell, now the configuration becomes something like this. I'm just copying the first two shells. I'm not going to draw the third shell because already it lost the third shell electron. Okay, now this is the new configuration. So now you tell me, when it loses electron, what will be the charge? Is it positive or negative? Yes, positive. When it gains, it becomes negative. When it loses, it becomes positive. So one electron is lost, right? So one positive. So let me keep this in the bracket and do not forget to write the charge. Okay. So now, how many electrons are there in the sodium ion? Sodium ion has 10 electrons. Sodium ion has 10 electrons now. Before it had, sodium atom had 11 electrons, then it loses one. After it loses one, 11 minus 1, now it has 10 electrons. Okay. So now can you tell me what is the noble gas configuration it attained now? Can you tell me what is the noble gas configuration it attained? It reached now. So it means what is the name of the noble gas with 10 electrons? Can you check the periodic table and tell me the name of the noble gas with 10 electrons? That is neon. You're right. Okay. So now I want to go over one more time. Sodium atom is there. It has only one valence electron. Then to become 8 electrons in the outer shell, there are two ways. Either it has to gain 7 electrons or just lose 1 electron. So losing 1 electron is easier than gaining 7 electron. So sodium loses 1 electron. It becomes the configuration of the sodium ion, which is given on the board. Now it has only 10 electrons, and finally it reached the configuration of neon, the stable configuration of neon. Just I have a curious question. Do you remember the name for the positive ion? The positive ion is called what? Cats have paws. So positive ions are called cations. So now can we see one more example? So this time I'm going to give an example which atom with the atom which will gain electrons. Okay, so I will. Okay, have you copied this one? Okay, if you copied, then I'll clear this. I'll use the same slide. So I'm going to pick different example now. Okay, so this time I'm planning to take Fluorine atom. Yeah. So example 2, fluorine atom. I know fluorine atom has 9 electrons. So 2 shells. So I have to draw 2 rings. First ring can hold 2 electrons, second ring can hold 7 electrons. Okay. So now my question is, how does the sodium fluorine atom behave according to Octet rule? So what will happen according to Octet rule? Whether the fluorine atom loses electron or gains electron. According to Octet rule, fluorine so we are going to find out this. Okay, let me ask you a question. How many valence electron the fluorine has? Correct, 7. So to become 8, what should be done? How many more electrons it needs? Already it has 7. So to become 8, how many more electrons it needs? So it has 7 valence electron. So to become 8, it needs how many more? Just 1 more electron. Just it has to add 1 more electron. You tell me, which is easy, just adding 1 electron or taking away all the 7 electrons from the outer shell to get the filled outer shell, which is easy. So I would say just gain or add 1 extra electron. So that's what. So now it gains 1 electron. So when it gains 1 electron, you have to put 1 extra electron in the second ring. So first ring and the second ring. So just I'm copying the electrons for the fluorine ion. So 1, 2. Then in the second shelf already it had 7. Now 5, 6, 7, and 8. Okay. So now it gained 1 electron. You tell me what will be the charge? When it gains electron, what will be the charge? Negative or positive? Negative. So it gains 1 electron, so it becomes negative. So it gives anion because you know negative ions are called anions. Negative ions are called anions. Okay, so now count how many electrons are there now? Totally 10 electrons. So if I ask you the question, what is the noble gas configuration it reached right now? You would say again neon. Neon. So now let me complete the question. So fluorine gains 1 electron according to Octet rule. So according to Octet rule, fluorine gains or adds 1 electron to become 8 electrons in the outer shell. The charge becomes -1. It has become anion. Now it has 10 electrons and reached the structure, noble gas structure of neon. Makes sense? Now I'm going to give you a practice. So I'm going to project the practice problem, pause the video, and put up the answers. Then we'll go over the answers. Okay, the practice problem, what I'm going to show is these notes are, see, these notes are given in Schoology. I posted the notes. So now I will do the practice problem. Okay, pause the video. Okay, now we'll answer the question. Look at this magnesium atom. How many valence electrons are there? Look at the structure. How many valence electrons are there? 1 and 2. So that is 2. So to become 8, what it should do? Either it has to add 6 more electron, or just it has to give away these 2 electrons. So which is easy, gaining 6 more or just losing 2? Obviously losing 2. So the magnesium loses 2 electrons. So how many electrons are lost? 2 electrons are lost. And what is the charge of the ion? When it loses electron, that becomes positive. So 2 electrons are lost, so positive 2. So the last question is, now it reaches the stable configuration of which noble gas? So after losing, it had 12 electrons, then it loses 2 electrons. Now it has, the magnesium ion has only 10 electrons. So the noble gas is neon. Did you get the same answer? If yes, give yourself a big thumbs up. So at this point, like, you have a idea about which atoms will lose electron, which atoms will gain electron, which is easier to do, whether losing is easier or gaining is easier, like that you might be having some idea. So I want to summarize the rules in the next slide. I would say like which will lose, which will gain, which will share, and all these things. So pause the video, try to pick the correct answers, to do the best guess. Then we will go over the answers. Are you ready with the answers? Okay. So there is a word bank: share, gain, lose, neither lose or gain. So according to Octet rule, if the atoms have 1, 2, or 3 valence electron, what it will do to become 8? Whether they lose or whether they gain, or lose or gain or share, which one they'll do, what they'll do. What's your answer? They will lose electrons. They will lose electrons. Because they have only small number of valence electron. It's better to give away those electrons instead of gaining the extra electrons to become 8. So lose. Then when the atoms have 5, 6, and 7 valence electrons, what they would do? They prefer to lose those 5 or 6 or 7 electrons, or just gain the remaining electrons to become 8. What's your answer? Obviously, gain. Because losing 5 electrons, 6 electrons, and 7 electrons is really harder than gaining 3, 2, or 1 electrons. So they gain. And when the atoms have 4 valence electron, like group 14 elements, for example, carbon, what do? They don't want to lose completely. They don't want to gain completely. And they want to make a good understanding. So they share. They share the electrons. They don't want to lose. They don't want to gain. So they would like to share the electron to become 8. Then the last thing, when the atoms have 8 valence electrons, that is group 18, What do? They neither lose nor gain. You know why? Because already they have stable configuration. Already they have stable configuration. Already they have 8 valence electrons in the outer shell, which is stable. So they don't want to lose, they don't want to gain. So neither lose nor gain. So this is the octet theorem. So you can watch the video again and let us know if you have any questions. Hope this helps. Thank you. Bye.